Hi, I'd like to welcome you to the Mathematica tutorial for Math 141 here at the University of Rhode Island. The first thing that we're going to do is open up Mathematica on our computer. So if we click the Mathematica icon, the following menu will appear. We want to create a new notebook. So if we go to the drop-down menu, we'll say that we want a new notebook, and this will open our very first Mathematica notebook. So a couple things to notice right away here. There's a plus sign on the left. If we click that plus sign, it allows us to choose how we want to enter our input. So the default input is called Wolfram Language Input, which is for mathematics. And also in this tutorial, we're going to be using plain text. So let's click plain text, and we'll put in the title of our Mathematica notebook, which we'll call My First Project. You'll notice that a bracket has appeared on the right. This bracket is representing a cell. What cells do in Mathematica is that they separate the kind of input that I'm putting into my notebook. So this will be a text cell. In order to create a new line, I just hit the carriage return or enter. And let's go and put a name for our project. It's very easy for us to go and change the font within a text cell. So if I highlight My First Project, I go and click Format, Style, I can go and make this the title, which just makes it larger and colors it red. You notice that I clicked underneath the text cell and my cursor is sideways now, and this will create a new cell. Mathematica will assume that you are putting a math input unless you go and change using the plus sign to some other kind of input. So let's look at our very first calculation, which in this case, let's say that we want to add 12/5 plus 5/7. So I can just type that in directly. And if I want Mathematica to evaluate a cell, I have to hold Shift and then hit return. So in this case, Mathematica made a common denominator and added the two fractions to get an answer of 109 divided by 35. Oftentimes I might want a numerical approximation of this. To do this, I want to go and type a capital N, and then inside square brackets, I'm going to put a percent sign. What the percent sign does in Mathematica is it goes and it will always be equal to the last output. So for us, the last output was 109 over 35, so the percent sign will be equal to 109 over 35. Again, if I hit Shift and return, it'll make a numerical approximation of 109 over 35. You'll notice that after you force Mathematica to evaluate a cell, it automatically starts a new cell for you. So what I want to talk to you about next is assigning a variable in Mathematica. So assigning a variable is very simple. So let's say that I want to set a to be equal to the square root of 2. You notice that right now a is light blue. Things that are light blue in Mathematica don't have a value associated with them. They're free variables. Notice that if I go and evaluate the cell, it returns square root of 2, and now the a has turned black instead of light blue. Things that are black in Mathematica have a value associated with them. And I can ask Mathematica later on, it'll remember that if I say, well, what is a? It returns, well, a is the square root of 2. It remembers that I set a to be the square root of 2, and I can actually use this within larger expressions. So I could say, okay, what is a squared? Well, since a is the square root of 2, the square root of 2 squared will give me 2. Another thing that I can do is I can actually use this to create new variables. So let's say that I want b to be equal to a plus 3/7. And then later on, it remembers that now b is the square root of 2 plus 3/7. So it's using the value of a to define another variable. Something that I want to be very careful about in Mathematica is that if I want to multiply two expressions, so now if I wanted to multiply a times b, I want to put a space between the a and the b. If I went and said ab with no space in between, Mathematica thinks that I'm assigning a new variable that I'm naming ab, and I haven't given it a value yet, so it's just going to return ab. If I have the space in between, it's taking the value of a times the value of b, just like what you see right here. I can also create more complicated expressions using the math palette. So let's say that I want my expression 1 if I go up to palettes and basic math assistant. Let's say that I want this expression to be equal to e taken to the power of, let's say 5 plus, if I go over here, let's say tangent of t. I can always create the same expression using direct commands rather than the basic math assistant. So for example, I can write that as the exponent of 5 plus tangent of t, and it'll give me the same output. But while you're starting off, the basic math assistant is an easy way to put in more complicated functions. There are shortcuts to be able to go and have the output be a little bit nicer. For example, if I want to write a squared, what I can do is type a, and then if I hit Control 6, it automatically makes a superscript for me, so I can say a squared. Or if I want to write 3/7, I can say 3, and then Control /, and it automatically makes a fraction for me, sevenths, and so on. The next thing that I'm going to be looking at is how to factor a polynomial in Mathematica. So let's go and define two polynomials for ourselves. Let's say polynomial 1 is equal to x cubed minus 9x, and we'll make another polynomial which we'll set equal to x squared minus 7. In order to factor a polynomial in Mathematica, what you want to do is use a capital F factor, and then inside inside square brackets, put in the polynomial that you want to factor. So for the first one, that factors into minus 3 plus x times 3 plus x. If I try to factor the second polynomial, you notice that it's returning that polynomial back. It's still minus 7 plus x squared. So factor always will try to factor in terms of integers. So to see this, let's go and try to go and solve for the roots of these polynomials. So let's talk about equations. In order to solve an equation in Mathematica, you use capital S solve. So for example, I could say, when is the first polynomial equal to 0? So the syntax here is like this. Notice that I have to have two equal signs. So if I just have a single equal sign, that's assigning a value to something, like when we set a equal to the square root of 2. If I have two equal signs, that is as an equation solving for when the polynomial will be equal to 0. And the second x here is saying that I want to solve this equation in terms of x. So if I hit Shift Return, it's giving me the three roots here, minus 3, 0, and 3, which we could see from the factorization of the polynomial. You notice that if I solve the second polynomial, that the roots were minus the square root of 7 and square root of 7, which is why when I used the factor command, it didn't return a factorization, because obviously the roots are not integers. I can also have Mathematica solve equations where the answers are complex. So for example, I have x squared plus 4 is equal to 0, which doesn't have any real answers, but it'll go and return the imaginary answers for me. And I can also tell it how, or tell Mathematica how I'd like it to answer the question. So for example, I can say, solve that equation but give me only the real answers. In which case, well, we can see from the line above that there isn't any real solutions to that equation, so it just returns an empty solution. Although the solve command is very powerful, it won't necessarily solve every equation that you put into it. So for example, if I ask it to solve x plus tangent of x is equal to 0, it isn't able to do it, even though this solution does have, or this equation does have solutions. So I'd also like to talk to you about what's called the replace command, which comes in handy. So what the replace command does is it replaces one thing with another thing. So for example, if I have x cubed minus 5x plus 4, and I want to plug in 0, one thing that I can do is I say /dot, which is the replace command, and then I say I want to replace x with say 0. So I'd be plugging 0 into that polynomial, and the output will be 4. You can see that if I replace x with 0, the only thing that I'll have left is 4. And I can do this with more complicated things. So for example, let's say that I want to solve x cubed minus 5x plus 4 is equal to 0, so I want to find its roots. So it has one root of 1, which is nice, but then the other ones, perhaps I want a decimal approximation of these to figure out how large they actually are. So one way that I can do this is I'm going to go and set answer to be the output from the solve command. So you see, if I ask Mathematica what's answer, it's these things. You notice that inside answer here, we have x and then right arrow 1, x right arrow to the second root, and x right arrow to the third root, which looks exactly like what we had up here when I said x arrow to 0. So what I can do is I'll say I want a numerical approximation of x, except I want to replace x with answer. So I'm replacing x with 1, I'm replacing x with the second root and with the third root. If I do this, it'll give me the decimal approximation of each of the roots. So 1, and then the other 2 roots, which aren't as nice. Okay, the next topic that I'm going to be talking about are functions in Mathematica. So first off, how do we define a function? The syntax looks like this. So you notice that I'm using t and then the underscore here, and what the underscore does is it tells us what the independent variable of the function is, and as soon as I use that underscore, it changes the color of the independent variable to green. You notice also that I'm using dots in front of the equal sign. If I hit shift and then return, you'll notice that the f turned from light blue, meaning that it didn't have a value, to black, meaning that it does have a value now. So I can ask Mathematica what f of t is, or I can ask what f of x is. So I'm able to go and put in any expression that I want inside the square brackets, and it puts it into the function. One thing that I'd like to point out is that if I put a semicolon after f of x, it suppresses the input. It doesn't actually give me an input, which is important sometimes if you have a very long input that you don't actually want, or output that you actually don't want to see. You can use the semicolon so that it's not printing out pages and pages of output on you. So let's look. I can plug in, say, f of 0, f of 1, or f at pi, and it'll go and plug those right into the function for me. And I can find the numerical values of the output that I just had by saying n and then wrapping the percent sign with square brackets. Plotting in Mathematica is actually very easy to do. So the command that you want to use is a capital P, plot. You put in the function that you want to plot, and then in curly braces you say the variable and then the bounds that you want to plot in between. So in this case, between, say, -5 and 10. And it will give me an output of the function between -5 and 10. It's easy to change the way that the plot looks if you click labels. It actually allows us to go and change the title of the plot. So let's call this my first plot. I can label the x axis to be x and the y axis to be y. I can go and set the plot to be whatever I want. I can change the font size. So let's make the font size, well, maybe that's a little too big. Let's make the font size 12. And if you click done, it goes and does all of those things to your plot. You can also adjust these manually. So if I go and plot the same function again. So let's say in the last plot, I didn't like the y-axis. I wanted it to go down lower and up higher. I can manually change the plot range to say between -15 and 20 if I'd like. And you'll notice that now I've changed the bounds of the y-axis from -15 to 20. If you look on the Mathematica website, there's actually a lot of documentation for all of the options that you can use in the plot command, and really in any command. So if you're interested in changing your plot in a certain way, you can always go and look at that documentation. So this will conclude the Mathematica tutorial, and I hope to see you guys again.